All right, we're going to look at Part B, problems 1 through 8, and we're going to work two together. So the first one we're going to do is number 2. So it says an object has a mass of 22.7 kilograms. So we're going to write our given. It's placed on a surface. The mass moves horizontally at a constant speed. I'm going to write constant speed in my given. This is extremely important because that means that the acceleration is 0. So I'm going to write that down so I don't forget that. The coefficient of sliding friction between the two surfaces is 0.94. So mu is 0.94. What is the force of friction? So I want to find F of F. So again, when I read the problem, I'm going to kind of chunk it. As I'm reading each little thing, I'm going to write it down. I'm not going to try and read the whole thing to the end because this way I'm writing down all the important information. The next step is to draw a free body diagram. Now I'm going to draw one of these for every single problem. So I draw a box to represent the object. Now, how do I know which way the box is going? Is the box going to the left or is the box going to the right? This is why my sign convention is important. So I'm just going to decide, I'm using the standard Cartesian sign convention that up and to the right is positive, and the box is moving, I'm going to call to the right because I want the direction that it's moving to be consistent with my sign convention. So now I'm going to draw all the forces that are acting on the box. Whenever we draw a free body diagram, the tail of the force always comes out of the center of mass. So in this case, it says it moves horizontally at a constant speed. And this is having, some of these maybe aren't worded, but there is an applied force acting on it. Did they tell us what that force is? No, but we don't need to find that. So this is Fa. The frictional force always acts in the direction opposite the motion. The force of weight always acts down. And the normal force always acts perpendicular to the surfaces in contact. So this is my free body diagram. Now I want to find F of F. When you don't know what to do, you go to the end. So the end is F of F. Well, first of all, before I even do that, whenever I have the mass in kilograms, I know I want to find the weight. So first I'll find the weight. F of G is equal to mg. So it's equal to 22.7 kilograms times 9.8 meters per second squared. Now I'm not putting the negative in here because see in my picture it's already pointing down. So I've already taken the negative into consideration from this negative 9.8 because I make it going down, which is negative. So now when I do this on my calculator, this comes out to be 223 newtons, F of G. So now, I don't know what to do, so I go to the end. I want to find F of F. So I look at my free body diagram. Which direction is F of F going in? It's going in the x direction. So if I sum forces in the x direction, first I write my sign convention. To the right is positive. And I'm going to say summation of F of x is equal to ma. Now I'm applying Newton's second law in that x direction. So is this box accelerating in the x direction? No, because they tell me it's moving at a constant speed, so this is 0 because this a is 0. So this is equal to 0. Now, instead of all this, this tells me I'm going to add up all my forces going in the x direction. So I'm going to look at my free body diagram, and instead of adding up all these forces in the x, I'm going to look. So I have Fa going to the right, so that's positive. And then FF goes to the left, so that's negative. So I have Fa minus FF is equal to 0. So that means FA is equal to F of F. The problem is they didn't tell me what this applied force is. And I don't know F of F either. So even though I know these are equal, I don't know that. So I'm obviously going to have to do something else. So again, there's three things I can do. I can sum forces horizontally, I can sum forces vertically, and I can use the mu equation. So let me sum forces vertically. Summation of F of Y is equal to MA. Is my box accelerating in the Y direction? No, it's not even moving in that direction. So this is 0. Now I'm going to replace this with my forces going in the Y direction. So I look at my free body diagram. Fn is up, is positive. So up is positive. Fg is down, that's negative. So Fn is equal to Fg, and I already found Fg, so Fn is equal to 223 newtons. Now I only have one thing left to do, because remember, there's three things you can do for a problem. One is sum forces horizontally, 2, sum forces vertically, and the last thing I can do is I can use my mu equation that says mu is equal to F of F over F of N. Now I have mu, and I have F of N, and I want to find F of F. So I'm going to rearrange my equation to solve for my unknown in terms of my known. So F of F is equal to mu times F of N. So it's equal to 0.94 times my normal force, which is 223. So F of F comes out to be 209 newtons. And that's it. Now when you do your homework, I expect your homework to look just like this. I expect to see your given. I expect to see your find. I expect to see your free body diagram on every problem. I expect to see your work. I expect to see this written out, summation of F of whatever is equal to MA, substituting in and solving. If you follow these steps, when we get to more complicated problems next week, they're not going to be complicated. They're going to be easy because you're just going to be following the same steps. You're not going to be memorizing.